Okay, so let's work on the first 7 there. If you get done the first 7, you can go on to the predicting stuff, but I'll go over the first 5 here in about 5 or 10 minutes. Okay, so number 7 goes a lot like number 6 does. We have that little thing where the NH4, the ammonium, is going to break up on the other side. Okay, so I would say let's probably start with that, just because that's going to be the trickiest part. It's also the biggest number, so it kind of makes sense to do that. So we got NH4 here. We have 2 nitrogens and 8 hydrogens. So I'm going to put a 2 here. That's going to fix the nitrogens. Okay, but I'm also going to have to put a 2 here to balance my hydrogens, because now I have 2 times 3 is 6 plus 2 more is 8, and I have 8 over here. So now the ammonium is taken care of. I have 1 sulfate, 2 sodiums. I'm going to have to put a 2 there to balance my sodiums, and that works because I needed that to fix my hydroxides there. So that's what we would end up with: 1, 2, 2, 2, 1. Okay? Tricky one? Right? It's a little bit tricky, right? It's not like impossible or anything. It's just a little bit different. Okay, can I go over 1, 2, and 3 from the reactions below? Yeah? Good to do that? Okay. All right, here's the thing with 1, 2, with 1 and 2 for sure, and probably 4 a little bit, but 1 and 2 for sure. There's more than one way to do this one, and they're both correct. Okay? I would imagine that most people wrote this reaction as potassium is added to water. Okay, because I said in replacement reactions, you should write water like it's an ionic compound. Okay, and if you did, you would have got this as your products, which is absolutely true. Okay, this is actually one of 2 reactions that happens when you add potassium to water. Okay, you're going to get this, which produces hydrogen gas, so you'll need a 2 here, okay, and you'll need a 2 here and a 2 here, okay, to make sure that everything balances. But you may have also written it this way. Which is also absolutely correct. Okay? Both of those things do actually happen when potassium is added to water. So, if I were to give you one like that on a quiz or a test, both reactions would be marked correct, as long as they were balanced correctly. Okay? Calcium added to water, same deal. You could have written it like this, which is probably the way most people wrote it, because I said to do that with replacement reactions. Right, so when we do that, we'll get hydrogen gas because it's special, and we'll get CaOH2, right? Because this is a 2 plus and this is a 1 minus, right? And then hydrogen's a special element. Then we got to go back and put a 2 there to make sure that everything balances. But you could have also written this, okay? Ca plus H2O will give H2 plus CaO. Right? And that's already balanced. You don't have to do a thing to it. Either one of those would be marked correct. Okay. Are we good? We said we were good to go over number 3, right? So I've got magnesium solid. That just means Mg. Okay. And nitrogen gas react with each other. Okay. What kind of reaction is that? It's still a synthesis reaction. Yeah, we're getting a lot of those. Okay, when they go together, which is what happens in a synthesis reaction, what kind of compound do I make? Okay, what do I have to do with that ionic compound? Drop and swap. Nitrogen's a -3, magnesium's a 2, so Mg3N2. Okay, now I need to balance. Nitrogen already looks good, it's 2 and 2. Biggest number is 3. I think we're good there. All right, I'm going to give you guys a little bit more time, and then I'm going to go over 4 to 7. Okay, if you get past that, just keep going. You don't have to stop and wait for me. For number 4, we got magnesium nitride. Hey, that's this stuff. Can I just transfer this stuff right down here and save myself a little time? Okay, so I got magnesium nitride. Okay, so that's a +2, that's a -3, so as we said, we can just transfer that compound from there to there. It's mixed with water. Now this is ionic. How should I write water? HOH. Okay, so we said it's a double replacement reaction. The pattern for that is that I swap the metals. Hydrogen acts as the metal here. Okay, so I'm going to get magnesium with hydroxide and hydrogen with nitrogen. Since those are both ionic compounds, they both need to be dropped and swapped. -1, +2, so brackets around the OH with a 2 outside. Okay, and then this is a -3, this is a +1, so H3N. Okay, biggest number is 3. It's on both magnesium and on hydrogen. Magnesium is the bigger charge. So I'm going to put a 3 there to balance my magnesiums. That gives me 6 hydroxides. So a 6 there balances my hydroxides, but then I'll need a 2 there to balance my hydrogens. Now I have 6 of those, and now I have 2 nitrogens on both sides, and now the reaction is fully balanced. Okay, number 5, we got a Roman numeral in this one. Okay, so definitely indicating an ionic compound. This is iron with the 2+ charge, with sulfur that has a 2- charge, so that compound is okay the way I wrote it. Reacts with oxygen gas, O2. Okay, what kind of reaction is that? Single replacement. Okay, the pattern for a single replacement reaction is that the element replaces the part of the ionic compound it's like. Oxygen's a non-metal, so sulfur is going to wind up by itself. Iron will end up with oxygen. Now, on this side, iron was a +2, so it's also a +2 over here. Okay, and this is a -2, so that compound is okay the way I have it written. What else do I need on here? Special element. I need an 8 on the sulfur. Okay, let's balance the biggest number. 8's the biggest number. Okay, 8 sulfur on both sides. Now I got 8 iron. 8 iron on both sides. Now I've got 8 oxygen. 4 times 2 is 8. Okay. 6 is one that throws people because there's something in here they have to do that they haven't had to do very often. Okay? Molybdenum sulfide, so MO and S. Sulfur is a -2. Molybdenum, weird, is a +6. When I drop and swap, I get 2 and 6. Or do I? I get 1 and 3. We haven't had to reduce 1 in a really long time. Okay, that's the whole reason I put this one on there, is to kind of trigger that, oh, we got to remember, if we can, we must reduce. Okay, 2 and 6 reduces down to 1 and 3, and that is reacting with oxygen gas. Okay, is that also a single replacement reaction? Okay, so again, the oxygen is going to replace the sulfur, so I'm going to end up with sulfur by itself. Okay, and now molybdenum with oxygen, +6 -2. Do I have to do the reduction thing again? Okay, so I'm going to get Mu3. Okay, on that side. Now I got to balance the whole reaction. I'm going to get some bigger numbers here. I got 8 sulfur, that's the biggest number, but I got 3 of them over here. What's the lowest common multiple? 24. Okay, so I got to multiply this side by 8 and this side by 3. All right, when I put that 8 there, it gives me 8 molybdenum. So I need to put an 8 there. 8 times 3 is 24 oxygens. What times 2 gives me 24? 12. Now it's balanced. So don't forget the reducing thing. It's pretty important. Okay, then I'm going to do 7, then I'm going to leave you guys to go ahead of me again. Obviously in number 7 we have the reduction thing because we're going to have Mu3 again, right? Molybdenum oxide. Okay, molybdenum oxide is MO capital O3, okay, because that's a +6 and that's a -2. Do the drop and swap and reduce. And it's reacting with hydrogen gas. Okay, what side of the periodic table is hydrogen on? Metals or non-metals? It's on the metal side. It can behave as a non-metal if it's listed second in a compound. hydrogen gas by itself is a metal. Okay, now that's weird because it's a gas, but if you heated any metal up hot enough, it would be a gas. Okay, it's just that hydrogen has a really, really low boiling point. Okay, so hydrogen is a metal when it is by itself. So in this single replacement reaction, hydrogen replaces oxygen or molybdenum? Molybdenum, yeah. Okay, so we're going to have molybdenum by itself and hydrogen with oxygen. Well, I'm pretty sure that's going to make that stuff. Okay, and it's okay to write it as H2O in this situation because it makes sense to. Okay, now I've just got to balance the whole reaction. Okay, I've got 3 oxygens over here. I've got 1 over here. So I put a 3 there. That'll give me 6. Okay, put a 3 here. I think we're good then. Okay, so like I said, some of these require you to go back to some of the rules we don't use as often. Okay, hydrogen defaults to metal unless it's listed second in a compound. Okay, I have to reduce ionic compounds when possible. Okay, keep going there, guys. I'll give you a few more minutes to get ahead of me again. If you get done these 13, you can move on to the ones below on that page. So we got lithium added to water, okay, because of the type of reaction this is. Probably wrote water this way, but if not, it's legitimate to write it the other way as well. What kind of reaction is that? Single replacement reaction, right? Okay, so since hydrogen's listed first, it's going to behave as the metal and it's going to get swapped out by the lithium. Okay, so hydrogen's a special element. This is a -1, this is a +1, so that compound is good the way I wrote it. Okay, now I just have to balance the reaction. A 2 there balances my hydrogens, but I'll also need a 2 there to balance the hydroxides, and then a 2 to balance the lithium. Okay, if you wrote it as H2O, okay, it comes out a little bit differently. H2O, okay, is going to give still H2, but Li2O. Okay, which will require a 2 there. Okay. All right, barium added to water, same idea. Okay, barium added to HOH. What kind of reaction is that? Single replacement, right? Barium's going to swap out the hydrogen. Okay, so we'll have hydrogen there plus barium hydroxide. Barium's a 2+. So we'll need brackets with a 2 outside of the brackets for that one for the drop and swap. And then we got to balance. A 2 there should take care of everything. Okay, so a similar structure, but the balancing is different because barium's charge is different. Okay, for number 10, I gave you the whole reaction because it doesn't really fit with our reaction types that we've learned. It's slightly different. Okay, biggest thing with number 10, copper 1 sulfide. So Cu with the 1+ charge with sulfide -2 charge, so we get Cu2S. Okay, and it is reacting with oxygen gas, O2. Right, and it's going to form copper 1 oxide, so +1 -2, so we're looking at Cu2O, and sulfur dioxide. Okay, so it doesn't really fit with any of the types we've gone over. It's more here as a trickier balance, and just more of a balancing exercise. So right now, copper's balanced, sulfur's balanced, but oxygen is not. Okay, there are 2 oxygens on the reactant side, and there are 3 on the product side. I've got an odd number. How do I get rid of an odd number? Double it. Okay, so I'm going to put a 2 there. Now that's going to mess up a bunch of other things that were already balanced, but that's okay. We can go back and fix those. Okay, I've got now 4 copper, so I just put a 2 there. Okay, it also gives me 2 sulfides, so I'm going to have to put a 2 there. And now I can finally go back to oxygen. Okay, kind of like a combustion reaction. Okay, so I've got 2 oxygens here. I've got another 4 here for a total of 6. What needs to go here? 3. Okay, is that a trickier balance? It is. Does it require any skills you don't already have? No, it doesn't. Okay, it just challenges you a little bit, which is the point of most of these. How many people have done 11? Okay, let's look at 11. All right, so we got aluminum reacts with iodine. What do I have to remember about iodine? It's special. Okay, what kind of reaction is this? Synthesis. Okay, when I combine aluminum and iodine, I'm combining a metal and a non-metal. What kind of compound do I get? Ionic. What do I have to do with it? Okay, aluminum is a 3+, iodine's a 1-. So Ali is supposed to be 3. Okay, 3 is the biggest number, but I have 3 on one side, 2 on the other. So lowest common multiple is 6, and look what I'm doing. Oh, I'm doubling an odd number again. Geez, that seems to work so often. Okay, so now I've got 6 there, 6 here, but I also have 2 aluminum, so I needed 2 there for the aluminum. How many people have done 12? Okay, I'll give you a couple more minutes, and I want to do 12 and 13. If you're done 12 and 13, like I said, keep working on the ones that are on the bottom, okay, that they're already in formula form. Okay, let's look at 12 and 13 here. So I've got silver nitrate. So Ag, that's a +1. So with nitrate, NO3, that's a -1. So that compound is okay the way it's written. Is reacting with copper 2, so 2+ copper, chloride. So that's a 1-, drop and swap. All right, those are my 2 reactants. They are both ionic compounds. What kind of reaction is that? Double replacement. Okay, pattern for a double replacement is swap the metals. So copper will end up with nitrate. Silver will end up with chlorine. I just made 2 ionic compounds that both need to be dropped and swapped. Nitrate's a -1. They told me in the reactants, this is the 2+ copper, so it still is in the products. So that means I'll need brackets and a 2. And then this is a +1, and that's a -1, so that compound is fine. The way I wrote it, it is dropped and swapped correctly. Okay, biggest number is 2. It's on both nitrate and chlorine. Okay, so it doesn't matter which one I do first. I'll balance the nitrate because it comes first. Now there are 2 nitrates on both sides, but that gives me 2 silver. So if I go over here, I balance the silver with that 2. I also balance the chlorine with that 2, and now the rest of the reaction is good. Okay. All right, and then we got barium chloride. So Ba, that's a 2+. Chlorine, that's a 1-, so drop and swap. With ammonium carbonate. Okay, so NH4, that's a +1. It's with another polyatomic ion, carbonate, that's a -2. So I'll have to drop and swap, and that means the ammonium is going to need brackets with a 2 outside of the brackets. Okay, what kind of reaction is that? It's a double replacement reaction. Ammonium, as we said before, acts like a metal. So it's ammonium and barium that have to switch according to the pattern. The metals switch partners. So ammonium will end up with chlorine. Barium will end up with carbonate. All right, I've just made 2 new ionic compounds. That's a -1, that's a +1, so that compound's okay the way I wrote it. This is a +2, this is a -2, so that compound is also okay the way I've written it. Chlorine and ammonium are both 2s in the reactants, but they are both 1s in the products. So what needs to go here? 2. Is everything else balanced now? It is. Okay, expect that on your quiz you're going to get ones that are of that level of difficulty. Okay, you know, you'll have some that'll have polyatomic ions, some that won't. Okay, but the balancing will be there. Okay, being able to identify and use the patterns to predict the products is what I'm going to be most concerned with. So make sure again you are going over those patterns so that you can identify that's double replacement, that's decomposition. Okay, and know what happens in each of those reaction types. Okay, now there were some ones below that. Wasn't those ones though, was it? Oh, yeah, these. Okay. How many people are done these ones? Okay, let's have a look at those then as well. Okay, so we got iron 2 chloride, so Fe. Okay, that's the 2 plus Fe. It's with chlorine. That's a -1, so FeCl2. Reacts with sodium phosphate, so Na. That's a +1. PO4 -3. See, I'm going to go over it. -3. Okay. When I drop and swap, that'll be Na3 PO4. Okay. What kind of reaction is that? Okay. What kind of reaction? It's double replacement, right? So we're just going to swap the metals again. So that means that sodium is going to end up with chlorine, +1, -1, so that compound's okay. And phosphate is going to end up with iron. Now we were told on this side that iron was a 2 plus, so it still is on the other side. It's with phosphate, which is a -3, so Fe3 brackets PO4 2. Okay, so biggest number is 3, and it's on both iron and sodium. So I'll do the iron first. Put a 3 there. My irons are balanced, but that gives me 6 chlorines. So I need a 6 there. That gives me my 6 sodiums. 2 times 3 is 6. That also gives me 2 phosphates. There are 2 phosphates over here. Should be good now. Okay. All right, then zinc oxide reacts with hydrogen chloride. Okay, we haven't done zinc very often. That's not one that comes up a lot. Zinc is a +2, oxygen's a -2, so that compound's okay that way. Reacts with hydrogen chloride. Okay, what kind of reaction is that? Double replacement, yeah. So we're going to swap the metals. Hydrogen will end up with oxygen, probably like that. Okay, and zinc will end up with chlorine. +2, -1, Cl2. Okay, biggest number is 2. It's on both hydrogen and chlorine, so that should fix the balance. Okay, how many people are, does it go up to 20 on your sheet? How many people have done all the way to 20? I'll give you a couple more minutes here and we'll go over up to 20. Okay, and then we'll start on that second batch tomorrow. Okay, let's go over these here before the bell goes. So copper 2 sulfate. Okay, so we got Cu, it's the 2 plus charge, it's with sulfate. That's a -2, so that compound is already dropped and swapped correctly. And it reacts with iron. Okay. This is something we haven't talked about, or maybe I talked about it once and you've probably forgotten it. Okay, what kind of reaction is this? Single replacement. That means iron has to swap out with copper. So copper is going to end up by itself, but iron ends up with sulfate. Did it tell me which kind of iron it was? And it can't, because when iron is an element, it doesn't have a charge. But I also have, because I'm predicting this, no way to figure out what charge iron has. Okay, because I wasn't given its name in the products. I predicted the products. So here's the rule. The charges listed for multivalent metals are listed in order of commonality. That means whichever one is the most common is listed first. For iron, that is 3 plus. That is the most common charge. And if you have no other way to figure it out, that's what you go with. You assume, and you know how assumptions are, right? Okay, but we assume that it's going to be the most common, which is a safe assumption in most cases because it's like 98% is that much and 2% is the other. Okay, so we can safely say this is the iron with the 2 plus, or sorry, the 3 plus. Okay, and this is 2 minus. So we will need to do this on our drop and swap. Okay, I would say you could expect to get one like that involving that rule on Friday's quiz. Certainly on your assignment and exam as well. Okay, little exceptions are the things that we want to make sure we know. Okay, for balancing, okay, we got to put 3 here for the sulfate because it's the biggest number. 3 there for the copper to balance the copper, and a 2 there for the iron. Okay. Good work today, guys. Don't forget your phones on the way out. Okay. Tomorrow, more prediction stuff. Lots more of those little weird rules.